Hi, it's Bob Walmsley here from INSYDIUM, and in this free tutorial we're going to look at recreating this fantastic sand advection scene. So we've got this really nice granular sand simulation. This is one of Mario's scenes, and we have got this sand being exploded apart by an ExplosiaFX sim. So let's jump into Cinema 4D and recreate it. So here we have this X-Particles logo model, which you can get from our content repository. So that's all we've got in our scene, and what we want to do is let's just put this, we want to skew it a little bit. We don't want it to be completely head on, so we'll just change some of these orientation settings. Let's change that rotation. Something like that is a bit more interesting. Obviously, you can spend way more time making it perfect. Right, so that's that. So what we need to do is we need to fill this volume with particles. And so before we start, let's bring in an X-Particles system so we can stay organized. And in the system menu, I'm just going to go to the object tab and I'm going to disable icon in viewport. And then in the emitter, I'm going to go to the object tab, and we need to go to the emitter shape and set it from rectangle to object. And let's put our XP logo in the object. And then all of the other settings you can actually ignore in this tab, because in the emission tab of the emitter, we're going to change the emission mode from rate, which just spits particles out, to hex. Now, hexagonal is really interesting. One thing we must do, we don't want to omit all frames, we just want to omit on one frame. So let's put 0 to 1, and we don't want any speed. So that's it. So what I'm going to do, I'm just going to make the geometry invisible. Let's just go forward one frame. And you can see that we're kind of getting these particles inside that volume, but there aren't that many of them. So let's just do a couple of things. Let's change the display mode of those particles so we can see what's happening a bit better, from dots to circles filled. Respawn them. So there are particles, and I'm just going to go to my options, to the OpenGL options, and I'm going to activate the viewport ambient occlusion, which is going to help us see these particles. So there aren't very many at the moment. We need more particles. So the way in which we control that in hexagonal emission mode, let's go back to the emitter, to the emission tab. The way we control it is via the particle radius. So what it tries to do, it tries to fill the volume using a three-dimensional hexagonal grid based on the particle radius. So if I put this down to 2, it's going to spawn more particles because they're smaller, so you can fit more in that volume. So let's just respawn, and there we're starting to see a little bit more of the shape of that X-Particles logo now. So let's go down to 1, and there'll be way more particles now, and there we go, we're starting to see the effect. Excellent. So this isn't kind of high enough resolution for our final render. We haven't got enough particles, but for now, whilst we're working on our scene, this amount is going to be good because we can visualize this as grains of sand, but it's going to run quickly in the viewport. So we'll leave it at 1 for now. When we get down to final render time, we might want this way down at like 0.2 with, you know, 250,000 particles. Let's see. So it's taking a lot longer to process now, spawning those particles in an hexagonal grid, but that's because there's just so many particles being spawned now. If I dolly in, so we've got an awful lot of particles there. These are being drawn as full circles, and we've got this ambient occlusion, so we've lost some of that viewport performance. But that's kind of where we're going to be at final simulation and render time. Let's just stick that back up at 1. And then it's going to be much more manageable as we sort out our scene. So let's just, in case we need it, put some more frames on our timeline as well. Good. So what do we need to do? We need these particles to act kind of physically accurate in 2 different ways. We need them to act like grains of sand, and we want them to kind of clump together and then snap and break apart. So that's a fluid granular solve that we need. But we also need them to float upwards in an organic way. And we're going to do that with another dynamic solver, and that's going to be with an ExplosiaFX explosion. So I think we should sort that out first. So what we need to do is go to the Dynamics tab of our system object, and the object we're going to choose is ExplosiaFX, and here's our domain. Now, because we're not rendering the smoke and the fire itself, we're just using it to push around particles, we don't need a high-res sim, which means we can increase the voxel size, makes it a lower resolution, less detailed sim, and it means it'll work it out much more quickly. So we'll try it at 7. Okay, that's fine for now. And let's just make that invisible. So now what we want to do is we want to create an explosion that is going to push our particles up. So the way we're going to do it is we're going to use another emitter as the source of the fuel. So let's go to the emitters sub-menu and create an emitter. And this one, let's just rename it and call it emitter EFX for ExplosiaFX. And in that one, in the object, we're going to make it a box. And I want the box to be kind of halfway up the logo, so something like that. Okay, good. So we want the box. If we let's disable that. If we hit play, what's going to happen is that these particles are going to come from the volume of that box in the direction of the faces of that cube. So you can see that's happening. So you can pick whatever you want. You can have it to be on any of the axes. So we want them to go upwards, so we're going to put +Y. So now they're all starting in that volume and they're going upwards. Excellent. So let's go to emission. I don't think we probably need 1,000. Let's go with 300 per second. We definitely don't need them going up this quick, so let's put it down to, say, 40 with a 20 variation. Full lifespan's fine. Okay, so that's looking all right. So this is going to ignite. This is going to be the source of our explosion. So we need to give it some fuel data. So let's go to the Extended tab, to the Physical Data tab, and let's just give it 2 fuel. Excellent. And if we switch on ExplosiaFX, it still doesn't light. And that's because we need a tag so it can communicate with our ExplosiaFX object. So let's go to Tags, XParticles Tags, ExplosiaFX Source, and let's see if we get an explosion, and there we go. Very undetailed, blobby explosion, but all we want this for is the velocity information. So what we can do, we can visualize that. If you go to the ExplosiaFX object and go to the display, we can change the display from fuel and smoke to velocity, and there is the velocity data that we're going to be mining to put into our other particles. Right, good. So it's not quite right yet. It's rising up. Let's just keep it on smoke for now. It's rising up way too quickly. It's going to make our sand go shoot up, and that's not what we want. So what I'm going to do in the ExplosiaFX, I'm going to go to the Simulation tab, and we're going to reduce this gravity slider. Now remember, by reducing gravity, this doesn't mean that the gravitational force of being pulled down to Earth is being weakened. That's not what this gravity slider does. What this slider does, it acts as a strength slider for these 3 buoyancy amounts. And at the moment, the buoyancy is making the smoke fly upwards. So if I reduce the gravity amount, it's going to reduce this buoyancy overall, and it's not going to float up as quickly. See, it's much more of a slow rise. I think we can maybe go even lower than that. All right, and maybe even lower, 0.5. Okay, good. Now, the only other thing I don't want any lingering smoke here. I want it to be all going in this direction, albeit slowly. So the way I'm going to do that is I'm going to go to the tag of the ExplosiaFX source, and with the velocity, I'm just going to put the velocity up to, say, 300, which is going to make this smoke respect the velocity of the particle, but it's amplifying it somewhat because we're doing it by 300%. Okay, so let's just make that invisible. And we can make this emitter invisible. I think, you know what, I think we've still got too many particles coming out of this. Let's go to the emitter emission, and let's put this down to say 100. We could always, this is still all procedural at the moment, so we can make adjustments should we wish. Nice. So let's make that invisible. Right, so what do we want to do? I want this smoke to push the sand. So we need to go to the ExplosiaFX, into the Advection tab, and activate it. Now a couple of things have happened. All the particles have gone black, and they're kind of moving with the smoke, but some of them are kind of sticking around here. And it's all acting a bit weird now. What's going on? Well, this is a bit of a gotcha. We are using as an emitter source particles, and the particles which are being ignited are also being advected by the fire once they've created. So we're getting this really bad loop that's not working properly. So in our emitter particles, our ExplosiaFX particles, we need to go to the modifiers, and we want to exclude the advection by dropping in the ExplosiaFX. And now that isn't happening. And finally, I'm going to go to the Advection tab. This is all of the data that ExplosiaFX can generate and then pass into the particles. And we don't need colour or smoke or burn or temperature or UV. We just want the velocity data. And now we have got it moving up in the kind of way that we want. So they're being advected, but they're not acting like sand. What do we need to do that? Well, we need to do a couple of things. We need another dynamic solver to turn those into sand. And we'll go to the Dynamics menu, and we will pick XP FluidFX. Now, before we move on, there is another thing we need to do. So in the ExplosiaFX one, we had to disclude this emitter from being advected. So we need to do the same thing with the FluidFX. We don't want these to be affected by any kind of fluid simulations. So let's go to FluidFX and drop that in there as well. Okay, excellent. So what we need to do to make these sand particles, let's just change that to emitter sand. What we need to do with those sand particles is tell them what kind of fluid to be. Do you want to be water, or do you want to be grains? Now we want it to be sand, so it's grains for us. So we'll go to Extended Data, Fluid Data, and we'll change the fluid type in the emitter from liquid to granular. And just straight away, I know I'm going to want 100% in the friction. So now let's see what happens. So it's changed ever so slightly. We're kind of getting a few clumps, but not many. Now, this is key when we're doing fluids, especially grains. The more sub-steps that you have and the more iterations that you have, the much more kind of cohesive your granular solve is going to be. And the way that we get more sub-steps and more iterations is there's two different ways of doing it. You can use the cheaty way, which is the way I always use because it's fast and I like it, is just by changing the accuracy preset. By default, it's set to fast, which means everything will work really quickly, but the sim won't be that accurate. If we move it all the way through to these higher settings, it'll be much slower, but you'll have a much more accurate sim, and the grains can be far more kind of clumpy. So let's just put it onto high, which is another preset, and leave everything else as default and see if it has any change. Now what we should see is that the particles are sticking together a bit more. Yeah, and we're getting bigger clumps as they're breaking off. We've got a better, more accurate sim. We've got more substeps and iterations going on. That's what the high preset does. And now it is far more clumpy. So that's nice. I'm just going to leave it on high for now. If you have used these types of fluid solvers before and you're very comfortable with things like minimum and maximum steps, CFL value, iterations, min and max, you're able, if you want, you can just go into custom, and then you've got full control over all of those SPH fluid simulation values. But if you haven't, I'd just urge you to use the fast presets and use fast for kind of drafting, go up to high or accurate for final render time. Okay, so that's kind of fine for now, and I'll leave it as it is. That's working okay. But we don't want all of those particles to start advecting immediately. We want them to advect from the top down. So how do we do that? Well, what we're going to do is we're going to use particle groups. So let's go to the XP system, to other objects, and I want to bring in a no, it's not another object. Where is it? It's in the groups menu, of course. Groups, create group. Okay, and I'll just leave it at that for now. So actually, let's just change the color of this group, make it pink. So at the moment, particles aren't being put into the pink group because we haven't told them to, so they're just staying in the green one. Now, if I go to ExplosiaFX, to the Advection tab, and drag in particle group 1, the only particles in this whole scene that are allowed to be advected are the ones in particle group 1. Now, because we don't have any particles in particle group 1, we've lost the advection. It's not happening anymore. So what we want to do is dynamically move particles from their birth state into particle group 1, and then they'll start advecting. So we're going to do that with fields. So let's go to, well, we need a special modifier that's going to help us do it first. So we'll go to the modifiers, control modifiers, and let's go to the change group modifier. And the new group we're going to use is particle group 1. There we go. And let's just take editor display off so it keeps the same circles that we've got defined, but it's going to change the color dependent on the color that we put here. Okay. So if I hit play now, they have immediately been put into particle group 1, and then they should start advecting because we've set particle group 1 to advect in our ExplosiaFX settings, and it's working as we would imagine. Fantastic. But we want to dynamically put them into particle group 1 from the top down. So we're going to do that using fields. So go to the change group modifier, we'll go to fall off, and we're going to add a box field. And let's just increase the kind of fall off of that field. Let's bring it up. There we go. So if I I'm just going to put my FluidFX down from high to medium so it runs a little bit more quickly while I demonstrate. So if we press play, no particles have been put into group 1, and as I move my field down, they get put into group 1, and you can see they're starting to advect. All right, so that's kind of the technique. So let's just think about keyframing this field. So we want to start with it here. Let's put a keyframe on the Y, and then as it comes down, maybe 60 frames-ish, let's put it down, and then they're all in. Keyframe again. Let's have a look. Okay, so that's interesting. I think we could perhaps make that a slower animation. So let's move that keyframe along. Yeah, that's nice. And they're coming in. Zoom. Okay, very good. And I think we can, it doesn't need to be quite this far down on the Y. So let's just put it, it doesn't need to be quite that low down. Let's try that. So it's going to move more slowly, and let's come down, passes them into particle group 1, and then they start to advect. Okay, and that's the basic technique. Let's just make a couple of adjustments. We'll go to FluidFX again, and let's put this back up to high. We might even want it on accurate. Let's come a bit closer. So here comes the advection. Okay, so that's interesting. I think they're slightly too clumped together. They're not breaking up enough. So let's go to our emitter sand, to the extended data, the fluid data, and I think we could reduce. Now, stability is a really interesting and important parameter. So what stability is saying is it's basically an amount of how far one particle can move in relation to its immediate neighbour before it is broken off. So if you have stability way up, it means that they have to be moving very fast away from each other to be able to break apart. If you reduce the stability, it makes it easier for two previously connected particles to be forced apart. So if we reduce this, we should get more of a breakup of clumps of our grains. Let's have a look. Yeah, so they're breaking off a bit more now. Okay. I think we could perhaps, let's just rotate this field ever so slightly and move it in the X there, just to see if we can get it feeling a little bit more random and it's slightly less uniform. Okay, good. And I've got a feeling that our ExplosiaFX is kind of moving a little bit too quickly, this explosion. So what I'm going to do, I'm going to go to the ExplosiaFX, to the simulation. I'm going to move all of that buoyancy out of it at all. So the only thing that's driving this upwards is the velocity of the particle that is being spat out by that emitter. And yeah, that's feeling better. That's feeling more clumpy. And then they're moving up. I much prefer that. Okay, that's looking good. So what we want to do at this point is we want to see what it looks like with a higher resolution of sand. But as we spawn more particles, we're going to get a much slower responsiveness in the viewport. So let's cache the ExplosiaFX sim at least. And then that means that it's not having to calculate this explosion every single time. It can just read it from the cache. So the way we do that is I don't want to cache anything but the ExplosiaFX. So we'll go to the other objects menu and we'll bring in a cache. And this cache, I'm going to go to this inclusion tab and I'm going to set the mode from exclude to include, and I'm just going to put in the ExplosiaFX. So all it's going to cache now is this simulation, nothing else. I'm going to change this just to internal memory, and let's have a look. That should be fine. So let's build cache. So what this is going to enable us to do is we'll be able to disable this emitter EFX because we won't need to use it anymore because the explosion will be put to cache. And then we should be able to have slightly better viewport performance when it comes to messing around with our fluids. And you can see this is caching pretty quickly. We're up to frame, we'll go up to 200 and that should be fine. And there we go, 200. So hit cancel. If you hit cancel, it keeps the caches that you put up to the point where you cancelled. So I've got 203 frames cached. So I'm just going to put 203 in the timeline. So now what I can do is I can switch off one emitter. So now it's just the sand that we're worrying about. And because our ExplosiaFX has been cached, we're still going to get that nice advection. There we go. That's looking very cool. So one other thing we could do to randomize a little bit further, I'm not entirely sure how successful this would be, so let's just keep it. So at the moment, as our box fall off, goes from in to out, they're obviously being swapped into a different group, but we're getting this very uniform line as they're getting put into that group. So let's see what happens if we can, let's see if we can break that up a little. And I think we may be able to do that by going to the change group modifier, and let's just reduce the probability of change. So this will happen per frame. So not all of the particles should be thrown into that new group as soon as they get within this fall off line. Let's see. I'm not 100% sure. Let's have a look. Yes, okay, so that is a much more broken up, isn't it? You can see that it's more broken up the line. That's interesting. I think that's going to work for us. So I'm going to, let's just reduce that a bit more. And see if this is going to give us a more random look. That's definitely breaking it up more. Okay, good. Well, I quite like it. We'll leave it for now. So let's go to my emitter sand and let's just try a higher resolution. So we're at 1 centimeter radius, which is giving us a lot of particles. But if we reduce this, we get more particles. So let's just put like 0.7. So a lot more particles are going to be spawned. Let's see what difference that has in the simulation. And it will have a difference. Let's have a look. Here it comes. So you can see it's running more slowly because it's having to work out so many more calculations. So I can think there's an argument to suggest we're getting much more nice clumps now, as you can see. Yeah, I mean, I'm pretty happy with that. That's okay. That's looking all right. So just before we move on, let's just see what happens if we put the accuracy of FluidFX from high to accurate. So this is going to give more iterations, more substeps, making the simulation much more accurate. And it'll take longer to process, of course. So you can see the difference in speed, much slower, but we're going to get a far more accurate and hopefully better looking sim. So let's just see what happens as it comes down. Now we may need to reduce the structure of our grains. Now that we have more particles and it's a much more accurate sim with more iterations and substeps, we may need to reduce it to break these clumps up a bit more. You see, we're getting these big, long bits that haven't broken. And that's a result of more particles and more substeps and iterations. So let's go to our sand emitter and into the extended data. And let's put the stability down to, say, 5. And fingers crossed, that should mean that we're going to get more clumps as particles break away. We could also reduce cohesion, which is it's a bit like a kind of a springy constraint that holds them together. If you go high on cohesion, you can get some almost like soft body type looks from your grains. So let's have a look. We've reduced stability, so I'm hoping that we might get a few more clumps breaking off. Yeah, so it's more likely to break. Yeah, we're getting another break here that we weren't getting before. This is breaking up more. Okay, that's good. And what really makes this sim is when you get these lower down bits intersecting and colliding with these lumps and then further shattering and breaking them up, it gives a really nice look. Now, arguably, I'd say that now perhaps it's been broken up a little bit too much. Do you know what? I'm just going to put that up to 7 and I'm not going to preview it. So that's looking really nice. So what I'm going to do is this. Because we want to move on to rendering it, but we want the rendering to be easy to kind of try out different looks. So let's cache this scene. So we're going to go to the emitter sand. Let's go to emission, and I'm going to put it down to, I mean, I said in production, I think you're going to want 0.2, but I'm not going to go that low for this. Let's go to 0.4. Okay. And then I'm going to go to my cache object, and I'm going to go to inclusion, and I'm going to put in the sand emitter. I'm going to reactivate the XP emitter EFX so we get our explosion working. So everything's as it should be. Okay, let's go to object and we'll go to build cache and overwrite. Now, this is going to take a while. I would say, at a rough guess, about maybe 10 minutes or so to get through these 200 frames. So what I'll do, let's pause for now. When this is finished, I'll come back and I'll tell you exactly how long it took, and then we'll move on to the next stage. Okay, so that took just over 8 minutes to complete. It says it down here in the info. Not bad, 8 minutes, 17 seconds. And we've got a huge cache size now. The memory used 1.32 gigabytes. So because I used the lazy person's option and cached these internally, it's fine, it works as a cache, but it just means that the Cinema 4D file for this scene is over a gig in size, which gets a bit unwieldy. So it's a further example, and I always say this, is don't be lazy. You're far better to cache to external files in its own folder, which can be kind of shared and stored far more sensibly and in a more organized way, I think, than using the internal cache. I'd save that for very small scenes. But so let's have a look. So what we can do, we've cached everything. We don't need the explosion anymore. We don't need anything. We don't need FluidFX. We don't need our emitter EFX kind of explosion source, because that's all cached. So we should just be able to scrub through this animation, which we can. Great. So let's just play it through. So we're getting some really nice small and big chunks. That's kind of what you want, really. And it's looking really nice. And we're getting nice interaction between the various different chunks as well. This one breaking off here is nice. So that's looking good. And the beauty of caching it, obviously, is we can scrub. And then that means, should we wish, you know, if we wanted to come in closer to this breaking clump here, you can see it breaking off. And it's all looking really cool. So the physics in this scene are working so nicely together. It feels so organic. It really is a fantastic technique, and we're getting these clumps breaking. And what's nice is when you get a lower clump banging into one above it and making it smash apart even more. So that's working really well. Excellent. So let's get on to rendering this and making it look good in Cycles 4D. So let's just minimize that system. And what we'll do, I'll jump into a different layout, which is better for demonstrating Cycles 4D, and we'll get on with the rendering. So here we are in our Cycles layout. Let's get cracking then. So first we'll bring in a Cycles camera, and let's just put a protection tag on that so we can't move it. Right, so what we're going to do, obviously the real-time preview is rendering now, but there's nothing there because we have no lights in the scene. So let's sort out the lighting first, and then we'll texture the particles. So to do that and to see what's happening, what we need to do is let's put like a holding texture on our sand emitter. So we'll go to Create, Cycles 4D, Surface, and we'll just make a diffuse. Standard diffuse, and stick it on our particles. And now what we're going to do is we're going to light the scene using objects, using planes. So we'll go to the object list here and we'll bring in a plane. Let's bring it down below. And what we need to do is make an emission material. So let's go to Create, Cycles 4D, Surface, Emission. Stick it on the plane. And you can see now our scene is being lit. So it looks like we're lighting our geometry as well. So yeah, look, XP logo, let's hide that from the render. So now we're rendering just our particles. So we don't want to render this from below, actually. Light this from below with our main light. We're going to go above. And then even just with it above, without doing anything, you can kind of start seeing that the effect is working. Great. So what we're going to do with this main light is we are going to make it a bit smaller, and we're going to kind of light it from above, but we want to create some nice kind of angled shadows and stuff. So let's just bring it out of the way, something like this. Now, obviously, if you're doing this yourself, give yourself plenty of room. Use all of your orthographic views should you wish to get this lighting right, but I'm just kind of eyeballing it with all this stuff open so you can just see all of these different windows. This isn't the way you should be working when you're doing it, and especially I'd advise working on 2 displays if possible. Right, let's whack up the strength of this emission shader up to say 100. Right, so there we go. We've got some nice contrast going on already, and even that just with one light, one plane making that light looks interesting already. Good. Let's change the colour of that. And we're going to go... Actually, no, I'm not going to change the colour of that for now. Because I want to make sure that the scene is correct first. So what I'm going to do is we're going to create our next light. So the next light, we want it to be acting as a... well, it's a kind of a fill light, really, but almost a rim fill light over these sides in this lightening up this shadowed area. And we're going to give this one a contrasting colour. So let's have a look. We'll come out that camera and let's make a new plane. And this one, we'll put it on the plus X. Do we want? Yeah, plus X. Let's pop it back here. We're going to have it thinner. And I'm going to rotate it up and I'm going to stick it down in world space, kind of lighting from there. We could perhaps move it behind. Let's just have a look. And we'll switch off our original one. Okay, so we're not seeing anything, and that's because we haven't put any light on it. So let's just put the same one on for now. Okay, so there's that light. All right, let's come out. I'm just going to move it back a bit. That way. Okay, good. So what I need to, I'm going to control drag this emission texture. This one is going to be my opposing coloured light, and this is going to go on my second plane. So I'll just replace that. Okay, and with this one, let's bring that strength down. Okay. Now, I feel like we're still getting too much light with this. I want it to be far less intrusive. I want to bring it back. I want it to be much more like a rim than a fill. Yes, so that is better. It's lighter in these areas. That's more of the look that I'm after. Great. And if we bring in the other light, there we're getting the effect that we want. And Mario in his scene in the content repository actually had another light, but for now I'm just going to leave it as it is. Arguably, we need a little bit more lighting in this area, which we might add later. But for now, I'm pretty pleased with how that's looking. So let's colour it. So our main light is this emission texture here, and let's just do it here. We could do it with black bodies and whatnot, but let's just do it the quick way. There we go. So that's looking pretty good. And the other one, we're going to make it a contrasting colour. So we're going to make it kind of like a cyan blue. Very nice. That's looking good. So I think now we've got that blue, and I think we could just bring up the saturation of this one. Yeah, that's looking good. And then I think we could even bring up the saturation of that cyan as well. All right, so that's pretty interesting. I'm liking that look. So this is too dark. This is too dark. This is a little bit too dark. I mean, I like the contrast, but I think it's just not working for this camera angle. And we can't have this much in shadow in the foreground. It doesn't really work. So let's add that third light. So the third light, let's just bring this one away a bit. The third light is going to kind of be lighting it from above again. It would be a smaller light. I'll scale that down. So I brought another plane here for us, and we'll bring that up, and we can have this quite close. So something like that maybe. And I'm just going to angle it in a little bit. And this one could, we'll see, we might have to change, but we could just give this one the same emission texture as the other orange light. Let's have a look. So that's brightened it up significantly, hasn't it? But the beauty of doing it that way is that it's brightened it up and brought this all, made it far more prominent, but we've kept that kind of nice blue fill stroke rim lighting, and we've kept some of that contrasted shadowing that we were getting when we just had a two light setup, so that's okay. Let's just try reducing the strength of this one down to say 120. Okay, so that's kind of all right. We'll leave that for now. There's no point in making more adjustments on the lights just yet because we haven't actually textured our particles. So at the moment, what we did, if you remember, we put a standard diffuse texture onto our emitter and it rendered them straight away as these spheres. And that's because by default, it instances spheres on particles. If you want more control, we have to put an instance tag on here, and that opens up lots of other opportunities. Let's just minimize some of these menus. Right, so let's go to the tags menu, Cycles 4D tags, and bring in an instance tag. And here it is. So what it's saying is instancing spheres with 24 segments and the position of our particles. And that's what's happening. And that's working okay. And what we're able to do, let's just dolly in a little bit. If I come right in close, so we can see the spheres clearly, yeah? But what we're able to do, which is really nice in the instance tag, is we can add some size variation. So let's put like 30% size variation. And now it's looking already a bit more random because we've randomized those scale values. They still are cohesive, they're in the right position, but we've managed to make it look a bit more random. We could even ramp that up to say 60% variation. And there's even more so. And if you change the seed, you're going to get slightly different looks. So that's kind of randomized things. But what we want is randomization of the texture as well as the size. And the way we're going to do that is by using instance objects. And we're going to use multiple objects to instance. And each object will have its own texture. So let's make that more clear. So what we're going to do is we're going to bring in a Cinema 4D sphere. Everything's gone black because the sphere's completely encased our scene. So let's put this down to a radius of 1. So it's somewhere buried in the middle of the scene. And what we will do is we will drag that sphere into our instance tag. And now instead of it instancing the default sphere, it's instancing this one that we've put in. So what we could do, let's create a new material. So we'll go to Create, Shader, Cycles 4D, Surface, and we're going to use a principled. So the principled shader is great because you can do diffuse with specular, you can do metals, you can do glass, you can do subsurface scattering, you can do all sorts. We're just going to do it as a default diffuse material, and for that we're just going to be using the base color, the specular, and the roughness. They're the only things that we're going to adjust. So let's put that principled shader on our sphere that we are instancing, and you can already see we're getting some specularity now from our lights. They're looking a bit shiny. Let's just whack that onto full so we can get the full impact of that specular. So now you can see we're getting a specular highlight, and that's because we are using the principled node that allows us to get that glossy specular. So if I just dolly in a bit further. So there's a couple of things to consider when we're using our principled shader. If we're going to be having a camera angle from out this far, we don't need to have a sphere with this many segments. This is creating a lot of geometry for each sphere, and it's rounding it off nicely, but we don't need that many for this camera angle. So if you reduce this, it's going to be much easier on the system and should work more quickly. So let's just put this down to 10. Okay, great. And let's now duplicate this sphere. So now we have 2, and I'm going to just delete the material from that one. And now I'm going to duplicate my principled shader, which gives me a new one. And this one I'm going to give it a black color, so it's completely very dark black. And I'm going to drag this onto my new sphere. And then in my instance tag, I'm going to drag in the new sphere. So now there are 2 spheres in the instance tag. And what you'll see is now Cycles 4D is instancing both of those spheres. One of them has the dark color, one has the light color. So we can get some really nice variation there. And if we change the seed, it'll redistribute them into different areas. So here, now we've got this as a very dark, we can very clearly see these highlights. If I add a bit of roughness, it's going to make them look less and less shiny. And look, they're starting to look a bit diffuse now with it spreading out. So that's also an interesting look. So we're not going to quite want it that. So what we're going to do here, we're going to colour this using the lights, and we're going to use this base colour just in grayscales to give these different brown and yellow and orange textures. So that's that one. So let's do it again. Let's copy the sphere. We'll delete that material that's on it, and we will copy this shader, and this one we'll give it a different grey, and we'll pop that on our sphere, and we'll move that sphere into our instance tag area, and now we've got more tonal difference between the two. Let's just do, do you know what, I'll just leave it as that for now. So what have we got? We've got one that's, let's make one really light. Okay, so now we'll go out to our camera view. So by doing that, we have got this variation of colour now, which obviously is far better. And what I'd urge you to do is use multiple spheres with slightly different textures on there, and you're going to get a really nice variation in your materials. And especially if you give them kind of different roughness values, you're going to get these different kind of textured looks for these spheres, and it's going to look really nice. Okay, that's looking good. So what else might we want to do? So we'll probably want to do some depth of field effects with this as well. So let's just get to this camera, and we can take the focal distance and click on this arrow, which allows you to pick focus in your scene. So let's say that we want, which bit do we want to be in focus? We want an interesting bit that's breaking away, really. Let's just look at this central area just for now. So we'll click that as our focal area. And then in the Cycles 4D camera tag, we can just increase this aperture radius, which is putting the rest out and making it blurred. And that's looking pretty good. So let's just kind of cycle through this. So there we've got the beginnings of the animation of the fracturing of the sand, moving its way up to the point where it's completely getting obliterated. And you can, of course, change the focal point to whichever bit you want, blurring out the rest, and you're getting these really nice sand-like effects. So that is the basic technique of taking a particle simulation and using the Cycles 4D instance tag to instance various different objects in that scene to get different looks and to get variation. And of course, we didn't have to just use spheres. Look, we could bring in, should we wish, we could bring in a platonic. Let's make the platonic, give that a radius of 1 as well. We'll give the platonic one of the principled materials that we've made. Let's drag that platonic into our instance tag, and now one of them has got more kind of rigid edges. If we turn off all of those, now it's all platonics. We could go with a, I mean, we could do, look, anything you like. Let's stick a capsule in there. Capsule, and we'll make it much smaller, 1 centimetre, 1 centimetre. Drag that into our list, and then we've got various different objects. So you can instance absolutely anything you want, and it can give you some really nice variation, and especially if you mix that with other colours, you're going to get this fantastic look. And then once you rendered out that as an animation, you're going to get this really nice flowing render. So if you've got any questions about these tutorials, please do go to the INSYDIUM Discord channel. All information about how you join that on the INSYDIUM website. And don't forget to subscribe to our YouTube channel as well, and then you'll get all of our latest free video content as soon as it's released. So that's it from me. I'll see you next time.